4.5, number 240. All right, f of x is e to the x on x. And the book is nice enough to tell us that x can't equal 0, but that's something we would have known anyway because x is in the denominator over here. So the domain of this function is clearly all reals except for the number 0. All right. The first part of this problem, and this is a fairly involved problem, is find the intervals where f is increasing or decreasing. To do that, we need to employ the first derivative. So we'll take the first derivative and set it equal to 0 and do a sign chart like we've done before in the examples. So first derivative, f prime, should be a standard quotient rule. So the bottom times the derivative of the top. The derivative of the top is itself, because it's the exponential function, base e, minus top times the derivative of the bottom, which is just 1. Don't have to write it. And then over bottom squared. We always want to clean these up as much as possible, which means factoring. So I'm going to take out the e to the x, and we'll have x minus 1 left over, all on x squared. And now we're going to do two things as usual. We want to know where this is equal to 0, which is usually the most important thing. Right? Is equal to 0. And we want to know where it's undefined. Undefined. Okay, so it becomes obvious pretty quickly that, e to the x is never going to be 0. We know e to the x is always positive. Right? Always a positive function. X minus 1 could be 0 if x were 1. Right? So if f prime of x is equal to 0, we get that x should equal 1. Okay? So there is a place, what does that mean? It means there is a place on the function where the tangent line has slope 0, right? Where the tangent line goes horizontal. And then we also have where the derivative is undefined. It's like, the denominator equal to 0 would give us x equals 0. So f prime of x is undefined would imply that x is 0. Now this 0 value is the same one we started with. That's not even in the domain of the function in the first place. Okay? Now we're just about to find where it's increasing, decreasing, and that will immediately lead into where you have relative extrema. So I want to point out something here. This value of 0, there is no function value there because x cannot be 0 for this function. So there's nothing going on there in terms of the function. So therefore, there's no slope there, and simultaneously there can be no relative extremum there. It's impossible because there's no function value there. Nevertheless, it could play a role, right, where the derivative is undefined. Even if this value is not in the domain of the original function, this could play a role in where the derivative changes sign, and therefore where the function changes from increasing to decreasing or decreasing to increasing. Okay? Even though, again, there could be no relative extrema there. So let's see what happens with our little sign chart. Two locations, 0 and 1. All right, so the first derivative. Going back to the factored form, we pick a number which is less than 0, say -1. Okay? We'll test -1. Test -1, the bottom is positive for sure. It's a square, so that's always positive. And this is always positive, right, because it's an exponential function. The only question is really on this factor. This factor controls the sign of the whole thing because these two can have no impact on the sign of the function. Sorry, the sign of the derivative there. So we look at -1. This factor would be negative, of course, if x were -1. So therefore, the overall derivative is negative here. Now we jump past 0, and we pick a test case between 0 and 1, and we'll test something like a half. Again, these two play no role. I put a half in here. It's negative as well. Right? And now, past 1, I'll pick the value of 2. Pick 2. I put 2 in here. Again, this one controls the whole thing in terms of sign, so 2 minus 1 is positive. Therefore, the whole derivative is positive on that interval.